Let's look at a few examples. How many positive integers are between 100 to 999 inclusive that are divisible by 7, that are odd, have the same 3 digits, are not divisible by 4, are divisible by either 3 or 4, not divisible by 3 or 4. We can think of a lot of these kinds of problems. What I want you to do is I want you to do these problems yourself. The answers are there on the next couple slides. But first, do it by yourself and pause the video at this point, and then you can see the answers after you have solved it yourself. So here are the solutions. So if I wanted to know the numbers that are divisible by 7, now it's hard to do from 100 to 999, but if I wanted to do from 1 to 999, that would be easy. We just divide by 7 and take the floor operation. Now, since we wanted to compute from 100 to 999, now we can select all numbers from 1 to 999, which will be these many, but we need to get rid of a few of them, which are the ones that are before 100, and so that would be 99 divided by 7, floor of that number, and we can get that as 128. We can do the same thing for odd. We can figure out how many are divisible by 2. Those will be the even numbers. Whatever is left would be odd. If there are same 3 digits, then it's exactly going to be 9 because it's 1, 1, 1, 2, 2, 2, 3, 3, 3, etc. If I wanted to know what are not divisible by 4, well, first find out how many are divisible by 4 and then get rid of those from the total number of numbers you have. Now, if I want the numbers that are divisible by either 3 or 4, in that case, I can count how many are divisible by 3, how many are divisible by 4, and when I count these, there are going to be some numbers that are going to be counted twice, namely those that are divisible by both 3 and 4, and so we should remove those duplicates from the list we have. Now we can continue. Not divisible by 3 or 4 is basically first find the ones that are divisible by either 3 or 4 and then get the remaining. If I wanted numbers that are divisible by 3 but not by 4, now these are the numbers that are divisible by 3. These are divisible by 3 and 4, so we should get rid of those from those 300 numbers. That's why we have 300 minus 225. And we already have this answer that are divisible by 3 and 4. This slide is quite dense, but in terms of what's happening, things are fairly straightforward. Pause the video at this time to see if you are comfortable with each of the examples on this slide. Now let's look at this next question that requires a little bit more analysis. How many ways can 3 numbers be selected from 1 through 300 such that their sum is divisible by 3? So let's look at the solution. The 300 numbers that we have, we can divide it into 3 parts. S0, these are numbers that are divisible by 3, so that includes 3, 6, 9, etc. S1, where if I divide that number by 3, the remainder will be 1, so that would be 1, 4, 7, etc. S2, which is when I divide that number by 3, I get the remainder of 2. That means numbers like 2, 5, 8, etc. Now I want the sum to be divisible by 3. That means I can select 3 numbers, all from S0 or all from S1, all from S2. If I do that, then the sum would be divisible by 3. Now I want you to think about whether there are any other combinations that will give you the sum that is divisible by 3. Pause the video here so you can have some time to think. Now another way we could get sum that is divisible by 3 is if I select one number from here, one number from here, one number from here, then the sum will be divisible by 3. And these are the only ways we can select numbers that will give the sum divisible by 3. So we can do selecting 3 numbers from S0 or selecting 3 from S1 or selecting 3 from S2 or one number from each set. So the answer that we are going to get, S0 has 100 elements. So the first one I'm going to get a C of 100, 3. Second, third is going to be exactly the same. For the third one, I need to select the first element. There are 100 ways I could do it. Second element, again 100 ways I can do this. And third element, which is again 100 ways I can do this. And this is this one huge number that we have over here. Once again, we have reached the check before you go ahead slide. What we did here was we split the formula into different parts, and for different parts we used the PNR, CNR formula appropriately, and then we combined it with the sum and product rule. And for all problems that you would solve in the context of counting fall into this sort of a situation where you partition it into smaller problems, each place where you can use permutation or combination, and then use the sum rule or the product rule to get the final answer. We have reached the end of the module, so please go ahead and do the review quiz at this time.